Why does the order you stack the layers of a neural network completely change what it learns? Watch 2 simple steps, in 2 orders. Start with a picture and a grid. Now do 2 bends, one after the other. First, a shear. Then on top of that, a rotation. 2 transformations, applied in sequence. First B, then A. Putting on socks, then shoes works. Shoes, then socks does not. Same 2 steps, different order, completely different result. So can one matrix do both bends at once? Yes, watch. Here is the magic. Multiply the 2 matrices together, and you get one single matrix, A times B. Apply that one product in a single step, and the picture lands in exactly the same place as doing both bends in a row. One matrix, 2 transformations, baked in. So why does matrix multiplication look so strange? Because each entry is a row, dotted with a column. Take the blue top row of A, dot it with the yellow first column of B. 1 times 2 plus 1 times 1 gives 3. The top left entry. Every entry is one of these little dot products. And here is the catch that trips everyone up. Swap the order and you do not get the same thing. Left, A then B. Right, B then A. Look, 2 different shapes. Matrix multiplication does not commute. A B is almost never equal to BA. Order is everything. Surely rotations are safe from this. In 2D, yes. In 3D, watch. Surely rotations are safe. 2 identical objects. The exact same 2 90-degree turns. But the left one spins flat first, then tips. The right one tips first, then spins. They end up facing completely different ways. In 2D, spinning just adds angles, so order never mattered. Add one more dimension and rotations stop commuting. Your phone's motion sensor, every robot arm, every game engine has to respect this order. And one special matrix does nothing at all. The most boring, most useful matrix. One matrix is special. The identity. One's on the diagonal, zeros everywhere else. Apply it and watch carefully. Nothing happens. The identity leaves space untouched. It is the number 1 of the matrix world. Multiply by it and nothing changes. Now the payoff. A deep neural network is just a long chain of these matrices, one after another. Layer after layer after layer. Every layer composes onto the last. And because order matters, the sequence of bends is the whole point. That is why deep beats wide, and why you cannot just shuffle the layers. So drop the most common mistake. Matrix multiplication is not multiplying matching boxes together. It is composition, doing one transformation, then another, and the order changes the answer. And you can prove it to yourself in 4 lines. Make 2 matrices, multiply them both ways with the @ sign, and print. The 2 answers are different. The full notebook is in the description. In one breath, multiplying matrices means doing one bend, then another. The product is the single matrix that does both. Each entry is a row dotted with a column, and order matters, so a B is not BA. That is why the order of your layers is everything. But here is a question. How do you measure how much a single bend stretches space in just one number? That is next. Next, a single number that tells you how much a matrix stretches space, and when it crushes space flat and destroys information for good. Thanks for watching and keep exploring. Next time, the determinant. Please like and subscribe ThirdEye Labs if you enjoyed this video and let me know in the comments.